Now that you're familiar with the basic function of switching, let's take a look at what Ethernet packets look like. Here's a scenario with two hosts. One host is sending an Ethernet packet to the other. Let's zoom in on the packet to learn more. An Ethernet packet operates on layer 1 and encapsulates the layer 2 Ethernet frame. The packets and frame are broken up into individual components. The packet starts with a preamble that is 7 bytes long, indicating the transmission of a new message. Then there is a 1 byte start of frame delimiter, which, as the name suggests, signifies the start of the frame. The layer 2 Ethernet frame starts with the destination MAC address and source MAC address, each 6 bytes long. As you learned earlier, these are the burned-in addresses that belong to the network interface controller's firmware. Next is a 4-byte optional header, and then 2 bytes of data that specify the frame type. Then there is the actual payload. Recall that this payload holds a structure of the layer above it. For instance, assuming that IP is used for layer 3, this payload would include IP headers and its payload. This payload would in turn contain TCP headers and its own content. This encapsulation runs all of the way to layer 7. The last component of the Ethernet frame is the frame check sequence, which is used to check on transmission if the contents of the frame have arrived error-free. Beyond the Ethernet frame, the layer 1 Ethernet packet has an additional component called the inter-packet gap. The inter-packet gap provides idle time that is required by the physical layer between transmissions.